We're about ready to move on to the second part of activity 1-2, but before we do that, we want to take one more measurement, and we want to know how thick a page is. It's hard to measure a page, but if I measure 100 pages here with this ruler, I did this a little earlier, and the thickness of 100 pages looked to be somewhere between 1.1 and 1.2 millimeters. So you can write that on your table for the separation. 100 pages was 1.15 centimeters. 1.15 centimeters. So if I have 1.15 centimeters, we have to do a little bit of a calculation to determine how thick is one page. If 100 pages has a thickness of 1.15 centimeters, well, how thick is one page, and how do I make that into meters? Let's convert to meters first. 1.15 centimeters is going to be, well, around 1/100th of a meter, because a cent is a 1 penny out of $1. A cent is 1/100th of a dollar. A centimeter is 100th of a meter, so 0.0115 meters. That's for, though, 100 pages. I want the thickness in meters of a single page. So I'm going to divide by 100 pages, and that's going to give me an even smaller number. I've got now 0.000115 meters for each page. All right, so what about 2 pages? Well, that'll be twice as thick, 0.00023. And you see the pattern. So now in your manual, you can fill out this column here. You should have the pages written down off to there. Now you can fill in all the measurements that we did. We may not have gone all the way down, but I think we got enough to see a pattern. And since your units are up here in the heading already, meters, you don't have to write meters in the table. So we've got the capacitance and we've got the separation. That's enough to do this bottom graph, but it would be kind of interesting to know what the area is. Don't put that in your table if you're doing the first part, because then you're going to get a graph on the top that's just going to be kind of a vertical line as we're changing as the area, because we kept the area the same for everything. This one, it's just going to be kind of a control that we have. You can fill it in if you want to, the length and the width, and then multiply for the area. Let's take that measurement now. So it's not so much the area of one of the pieces of aluminum foil, but the area that's actually overlapping. So I'm not going to count this part that's hanging out or the part that's hanging out at the top. I'm just going to go kind of from right about here. I'll go up to the top, and the length looks like it's about, we'll call it 25 centimeters. Let's convert that to meters. 25 cents is a quarter of a dollar. 25 centimeters is a quarter of a meter. 0.25 meters is my length. And my width is going to be roughly, we'll call that 17 centimeters. So 17 centimeters wide, 0.17 meters wide, 0.25 meters long is our length. So now we're ready to vary the area. I'm going to keep the separation the same. I've changed it back to 10 pages. And the thickness of one page is 0.000115 meters. So 10 pages is going to be 0.00115 meters separation between them. If you're making the graph, don't enter that into your data table in the software. Go ahead and put it in your manual, but don't put it in the software, because we're going to just focus on the graph that has capacitance and area, and we don't want to have the data for the separation, because we're not changing that for this second one. If you're doing the first activity, then you're going to need to know what the area is. Go ahead and calculate it. Don't put it into here if you're doing the separation, but do put it in your manual so you can calculate that and use it for some of the calculations on the second part. Here we go. 10 pages separation, and the area is going to be 25 centimeters times 17 centimeters. Convert that to meters. 0.25 times 0.17. And you can fill that. That'll be our first area. And I'll take a measurement now. Here's our first measurement. And we have a capacitance of 1.07 nanofarad. Now it'd be interesting to compare that to the first video to see, has anything really changed? I folded that top sheet of aluminum foil down at the top, so it's no longer 25 centimeters tall. It has the same width, so you can keep the width the same, which is about 17 centimeters. So keep that the same in that column, but let's now make the length, instead of 25, it's now 22. So in your second row, carry down the 0.17 for the width, and now make 0.22 be your length. And let's get a measurement for that. By the way, I'm not making the second sheet smaller. I'm kind of curious. I don't think I need to, because I think it's just the area that overlaps. But we'll see if this year's results are different from previous years. The capacitance is it's jumping around a little bit more than I'd like. Let's see if we can get it. I wonder if it's touching somewhere. Let me take a look. Okay, I shifted some of these sheets a little bit further away from the edge, and appears we're getting a little bit more stable reading. Capacitance of 0.9. Let's call that 0.91 nanofarad, 0.91. This little sign came on there. I wonder if I'm low on battery for this one. So I switched out the multimeter with my spare, and I don't think it really matters which way I put it, and we're getting a reading of 0.91. That's reassuring. So using two different multimeters, if I switch these around, I should get the same reading, 0.91. So the capacitance is 0.91 nanofarad when and now I'm going to change the area again. I've put another fold in the top of it. It's still 17 centimeters wide, but let's see how long it is now. And now we'll call that 19 centimeters. 0.19 for the third row. Our capacitance is 0.79 nanofarads. Folded it down again, stays 17 centimeters wide. The new length is 16 centimeters for the new length.
Dad, what can I do besides reading my Kindle?
I don't know. You can help me out, Lucas. So the new reading is 0.67 nanofarad. 0.67. Still 17 centimeters wide. Let's take a look at this. Now the length is, we'll call that 12 centimeters. 12 centimeters. I wasn't expecting that. All right, our new reading is 0.48 nanofarad. Dimensions are 17 centimeters wide. Now the new length is 9 centimeters, 0.09. So it's not 90 hundredths, but 9 hundredths. 0.09 is our length. Our capacitance is 0.41 nanofarads, or 0.40. Doesn't really matter. That last place is uncertain anyway. All right. We've got now a length of 6 centimeters, 0.06 meters. awfully small. This is curious. Let me do some testing. I suspect it wasn't it was the contact I had. Now I'm pushing a little bit more with the tips and I get 0.33 nanofarad. This will be our last measurement. We've got the same width as before, 17 centimeters, and our thickness is now 3 centimeters, 0.03 meters.